Hi, I'm Chris Lowe. I work for Manitoba Infrastructure for Construction Support Service, and I am the manager of the UAV program. So right here we have the Matrice 350. I oversee the drone program we have. We have quite a few advanced pilot operators and quite a few drones, and I just overview the whole program. This is our go-to drone for most of our applications. We use these UAVs for construction and surveying purposes. We use them for volume calculation and inspections and things like that. So here we have the DJI Mini Pro 3. We were an early adopter to this technology. We've been using photogrammetry with drones for probably almost over 8 years now. Some of the original drones that we were using for photogrammetry have become obsolete. That technology has already passed them by, and we're on to the newer stuff. But yeah, we're definitely an earlier adopter. We use this mostly for inspections such as like dikes, bridges, projects. If you want a project scope, you can go over and fly a whole project so you know where you are. Some of the projects we get to work on are volume calculations, so we'll fly gravel pits and stockpiles, and we'll get volume calculations for payment. And we also do inspections, so we'll inspect bridges and dams and dikes and fly places where it's hard to get and do some inspection. And the third is 3D mapping, so we can take 3D models of terrain. This is the SenseFly EB RTK UAV. It's a fixed-wing drone that we use for photogrammetry. So it has a camera payload down here. We get a lot of projects coming our way where we have to head out and fly in planes and go to remote areas and do some drone UAV work. We work with NAMA, which is Northern Airports and Marine Operations. So every 4 years we have to update the flight supplement manual for NAV Canada. So we fly into these remote airports, and I'll bring up my EB RTK drone, and we will 3D map the entire runway and airport. So we're all over the northern part of the province doing these 3D models of airports. It's super fun and exciting. You get to do a lot of traveling and see a lot of different types of projects. And you're in and out really quick with the drone because you capture a lot of data in a short period of time. So you're always on to the next thing real fast. Checking to see if my payload is secured properly and making sure that the lens cap is off. A usual UAV flight is about half an hour if it's a small area, but if you get up to say a gravel pit that's maybe a square kilometer, that could be easily up to an hour. And then post-processing, LiDAR is very quick. You can process a job in about 15 minutes. Photogrammetry, if you're taking a lot of pictures, it can be up to 20 hours to make your 3D model. We can basically go out to a bridge or dam site and fly a mission and capture a 3D model of the structure, and then that way we can send it off to drafters and they can do their measurements and design. So here's the maintenance yard I flew, and we can zoom in. This is actually not a picture, it's a 3D model that I created from the photographs. And we can kind of zoom in on anything we want here and look around our 3D model that we made with just taking photographs that were geo-referenced. Here's the Minnesota Dam. The project that we just did 2 weeks ago was at Minnesota Dam. Flew LiDAR over it, so we have basically a 3D captured moment in time of the whole site that we can take measurements from. I think there was an erosion problem at the Minnesota Dam, and they wanted to get a capture of what was happening downstream with the erosion, so they can come up with a plan to correct it. So we can zoom in and we can see that it picked up the dam pretty well here. For a normal project where we had to conventionally survey it using GPS and total stations, a project like that Minnesota Dam could take maybe 3 days to capture the structure in the outlying terrain. With the UAV and the LiDAR payload, we were able to fly it in roughly about an hour's time, and we have a complete data set of the entire area, and we can send it off to the drafters so they can make their models and their design. Basically, the data would go to our drafting staff, who makes the designs for construction. Yeah. This is PTH1 and PTH5, the intersection there. We flew a photogrammetry mission over it. Time saving is a big one. The amount of data collected is a big one. So conventional surveying, you have to manually log every point that you shoot. With LiDAR, you're capturing thousands of points per second almost. Where conventional surveying, you're basically capturing 1 point every 5 seconds. This is basically where it took every single picture. So this is how high I flew the drone, and every picture is kind of represented by one of these little squares. Saving money and resources, it definitely cuts down on man hours. I'd say that's pretty much the only area you're saving in. Because right now, currently, the technology is expensive to get into. You need the UAV, you need your payloads, you need a laptop that can run the software, and you need the programs that compile your information. So it's a big investment to get started.
Right.
The barriers, it is costly to get in with the more heavy-duty drones. And also the credentials to fly drones, you need to pass a few exams and get your certificates. That's another big one. And it can be kind of intimidating, I believe, to be flying these larger drones in some restricted airspace areas. Where drones need to go now is just where most technology goes, is lighter and less expensive. So right now we have a few drones, but it'd be nice if every survey crew in the province could have a drone someday. You can start small with photogrammetry, and then there's some cheaper photogrammetry drones that you could get into. But for what we do, we like to get some of the higher end stuff. I think the biggest way to show people of the technology is just showing them what we produce with our data sets, showing them the 3D models of the point clouds and the photogrammetry images. That usually gets people on board pretty quick.